how spatial insights revolutionize sectors in the digital age, addressing global challenges in security, sustainability, and risk analysis through cloud technology innovation. And to start this exciting panel discussion, I would like to invite the chairperson, Dr. V.S. Hegde, formerly Chairman cum Managing Director, Antrix Corporation Limited, and Scientific Secretary, ISRO. I would also like to invite our panelist, Mr. Phil Cooper, Geospatial Technical Business Development Lead, AWS EMEA, Ms. Divya Sharma, Vice President, Satsure, and Mr. Naresh P., CTO, Tathya. Now I request Mr. V.S. Hegde to please lead the discussion. Thank you so much.
Thank you so much, and welcome everybody for this particular session. And it is indeed an honor for me to be coordinating, I will not say chairing, to be coordinating this particular session on cloud technology for geospatial sector. Because I have been in my 4 decades or 4.5 decades of career in ISRO, I was on to Earth observation, disaster management support, and various other kinds of activities. But I was involved in creation of geospatial data or databases in the form of web portals, whatever, but I'm not a core technology guy. So today we are all aware that whatever we talk about building satellites, launching, it is all upstream activity, which is a part of 12 to 15% of the overall space economy. So it is really the downstream use and all the possibilities of how space along with other complementary attribute data can provide downstream is the one which decides the future of space activities. As ISRO Chairman Somnath also told this morning. But I think in the recent times we have been discussing less and less about the downstream activities, and I compliment SIA that they kept a session this time on making use of the power of cloud, because today the cloud technology makes and means everything when it comes to downstream possibilities, not only in the geospatial sector, every possible sector, whether it is healthcare too, and whatever. Okay, so just to make a few remarks as not as a techie, cloud computing has very much transforming geospatial technology by providing scalable, flexible, cost-effective solutions, and for handling large volumes of data, performing very complex geospatial analysis. It is not just to see or analyze what is readily available to you. The possibility is, say, if you have 20-30 layers of spatial data in your web portal, in your server or another mirror server or backup server, whatever, and some attribute data you would have collected and kept for your own studies, that is not the limit. Once you get into the domain of cloud, you can bring in so many possible or likely parameters into your analytics, and you can create the digital twin and simulate and see what happens or what can happen, things like that. And that is a kind of power. And I think in India, we are at the beginning of such revolution happening. So it provides you, the cloud technology in geospatial sector would provide greater possibilities of data storage and management, scalability of your whole geospatial analysis activity. Data processing and analysis will go into absolutely different kind of dimensions. You can have greater collaboration and sharing, greater visualization and mapping, and all will be far, far more cost effective than what we are doing today, because a techie can just be with a laptop with good broadband connectivity and the whole resource can be available to him. Not like, how big should be my server, what should be our storage capability, what should be our AC room, what should be cleanliness, because I'm talking what I have seen, I have gone through, okay? And disaster management response and all that. I mean, basically in summary, the use of cloud computing in geospatial analysis, collaboration, cost efficiency, and various things will come in, and thereby we will be far, far more efficient in planning, whether it is environment related or agriculture related, logistics related, could be anything. So we in India, I mean, to be a little specific, we have a web portal, Bhuvan, which is open to everyone, but not it's cloud enabled or whatever. And we have NRIS database, we have MOSDAC, for oceanography, meteorology, and we have national database for emergency management. But these are all sitting with those legacy organizations or ministries with, of course, appropriate backup, and maybe in the name of security. So that situation, I hope, will change now, and we will start exploiting the power of cloud technology to be more efficient when it comes to using geospatial data. But we have, of course, a lot of cloud service providers in the country today. We have Amazon Web Services, Microsoft Azure, Google Cloud Platform, IBM Cloud, Reliance Jio, Tata Communications, ISRO Cloud Platform, and NetMagic. So there are quite a good number of cloud resources available in the country today. So I hope, this will all get integrated soon, of course, with security concerns duly addressed as the matter moves further. Now, I'm extremely, extremely happy that I have, very, very well-informed core techies as co-panelists. We have Mr. Phil Cooper, Geospatial Technical Business Development Lead at Amazon Web Services. Last 23, 25 years, he has been into the core of geospatial activity. He has vast knowledge of using cloud technology for satellite operations, geospatial data analysis, and he has a passion for building systems of that kind. Phil Cooper lives in UK, near Guildford. So we have Ms. Divya Sharma. She is Vice President in Satsure. She heads the EO data team, in deploying ML, DL technologies. She is a seasoned professional. She has been into core of this activity for the last 15 years. And she also had, I will not say stint, a fairly few years working in US, this techie, and she has done her graduation, I think, from UCLA, right? Lovely place, anyway, I've seen UCLA. So she has relocated to India, and they are into using cloud as well as geospatial resources to give, customized service for agricultural activity, which is the backbone of our livelihood in India. So I couldn't interact with Naresh till few minutes ago. So I will request Naresh to talk about himself briefly, about his background and activities when he speaks. Now with this, I will close. What I suggest, if you all agree, since we have three core techies with us, they can give us, how geospatial technology or how cloud technology could do wonders with geospatial databases. They can give their own perspective and some key hints and all, because since we are to enter into that area in India, maybe 5 minutes each, 5 minutes each, or could be little longer, because 6-7 minutes you may need. Okay, 5 to 7 or 8 minutes each one of them can give their perspective or what they feel about. Because we want really whatever discussed here to come as one or two lines of recommendation in the conference proceedings. After that, maybe you all can, because the learned audience can ask some questions and post to them, not to me, okay? And if so, can I request Phil, you can.
Well, thank you very, very much indeed for inviting me here to speak today. Two very unique things have happened as a consequence of my activity in India this week. First of all, I've been invited to this fantastic conference. Thank you very much. And I'm very pleased that the Space Congress has organised a cricket match between England and India to watch tomorrow night. So thank you very much indeed for both those unique events. Just briefly to talk about geospatial data on AWS. We are witnessing a titanic shift to the cloud right now. In our particular sector, the sheer volume of data is growing terabytes, petabytes, exabytes. And the value that that data gives to our customers, to our partners, can be unlocked when working on AWS. Some of the biggest challenges that we have to face as humanity, with climate change, with sustainability, with environment change, the data exists. The data exists to access and process. If you look at United Nations SDIs, a third of them, I speak to the geospatial team at the UN, a third of them can be addressed by the use of Earth observation data, remote sensing data. If you look at the sectors such as geointelligence and security, Earth observation data, geospatial data has the ability to monitor, assess, review, and deliver intelligence where it's needed, when it's needed. Major infrastructure projects in India right now can be monitored, assessed, and delivered. The challenges are around data storage. So let AWS do the undifferentiated heavy lifting for you. Focus on the questions, focus on the analysis. Siloed data doesn't allow you to answer questions. Siloed data doesn't allow people to share interoperable data sets and work them together. So these are some of the challenges that we're looking at and the things that we're working on right now. I'm just going to refer to a couple of the areas that we work on right now. So Earth on AWS, which is an exemplar of this. Many of our customers, Satsure, Tathya, Pixel, started live working on Earth on AWS, the open data platform. It has 160 petabytes of data openly available for customers to start processing. Landsat. Hopefully, people are familiar with the Landsat program in the room. Been going since 1972. 53 years of satellite imagery data sitting on AWS right now. If there was ever a data set you could start your machine learning algorithms against, that's it. It is a colossally underutilized resource. But even so, when we first made Landsat available on AWS Earth, it had 1 billion requests in the first 6 months. That's where cloud brings power and scale. It allows customers to access and process data. It allows us to look at things like deforestation, agriculture monitoring, water loss, land change, land use, infrastructure change, and the list goes on. And so we have what I consider the three periods of EO. Having been in the sector now for 25 years, I've witnessed days when I started out of trying to process a single satellite image. When I back in the day of Idris-C, if anybody remembers Idris-C, or software products that would process data. And EO data wasn't plentiful, it was project-based. And then 10 years later, companies were promised rapid access to data, but there just wasn't that many satellites. I remember standing in a company I worked for a period with a director at the time. Insurance company rings up, there's a flood. We're told that satellite imagery can tell us where the flood is. We need to know the extent of that flood. Could you wait a couple of days until the satellite passes over so we can tell you where the flood is? and the utter lack of the disappointment on the faces of the insurance company. What do you mean I can't get it now? Today, with the number of satellites being launched, with SpaceX and Rocket Labs and Ariane Space, the number of satellites imaging the Earth every day, Planet, we work with Black Sky, we work with Maxar, the Earth is being imaged every day, every hour of every day. It's a lot of data. So if you look at those challenges that we've got and the way that we do it and how we secure data at source, it means that the opportunities are opening up dramatically for our customers and partners to build solutions on those open data platforms with things like Ground Station as a Service, with Amazon Location Services, with SageMaker, and now with the emergence of generative AI with Bedrock. The ability to inquire and query satellite imagery data is changing dramatically. I think some of the areas that we really want to look at is where that investment is made. And I look at TerraWatch, Aravind, who ran a fantastic summit recently, and he did some analysis. In 2023, $500 million was invested purely in data capture. 1.2 billion was in the applications from that data. So why is that relevant to India? Why is this going to be important to Indian nation as you develop and grow and work in these space programs? I've been very fortunate. I worked for an Indian company for a period of time. India is a nation of engineers, a nation of builders. Develop applications, develop services. The data is there to build on and develop. The skills that are required with that are not the skills of yesterday. Cloud skills, and that's where we're going to help with customers. We have space accelerators to help with our customers develop skills on cloud. Unlock the value of the data that you have today and start preparing for the data you're going to have tomorrow. And that's where partners like Satsure, customers like Satsure are already doing this in the utility sector, in the insurance sector, in the agricultural sector. It's happening now. There are many, many questions, of course, about security, and I'm very familiar with the geospatial policy in India. So we're delighted to have our regions in India to ensure the data remains in the country and adheres to those rules and regulations. It means that you can develop applications, develop things. The other thing as well, never be afraid to fail. Fail fast. DevOps environments. If you're using cloud environment, you're spinning up a compute device, you're using an S3 bucket with the data secured, you can be spending a couple of dollars. Experiment, doesn't work, that's okay. You haven't spent vast quantities of money on servers that you don't need. You haven't spent vast amounts of money maintaining servers. The money and investment in the applications and services, let us take care of the undifferentiated heavy lifting. As a geographer, I get to travel a great deal, and I'm always delighted to meet new customers and new partners and start new conversations. If you want to talk to me, find me on LinkedIn, Phil Cooper, you find me on LinkedIn. Please ask a question. Geospatial data on the cloud is something that we are seeing accelerating fast, and it's going to keep growing. Those exabytes are going to get bigger. Let us help you access that and focus the investment on the downstream and the applications. Thank you very much, and feel free to ask me any questions.
It's a pleasure to be here, and I'm glad Phil went before me. So I think it'll be a good idea. He gave us a view into from top to bottom, and I'm going to talk more about how these things have revolutionized our solving capability of the problem statements we would not have thought about solving. So to give you an example, at Satsure, we are trying to solve for low-income farmer inclusion, where, you know, in India, agriculture being our first sort of occupation and 70% of the population is already engaged with it, it makes huge scale problem to be get solved for, especially when you have low-income farmers who do not have access to the funds they want, especially when they are growing stuff. This is the first sort of disruptive problem statement we looked at. And if you look at just the problem, the scale of problem, you will be, or anybody would be terrified, because this is about India, a huge nation with, you know, we have double-digit states around, right? So to really solve it at that scale, we could not have put like an army of people to do, let's say, geospatial analysis, which is traditionally what the industry has been doing. Just because of the availability of data at this scale, and the democratization of data, which, the partners like AWS has brought in, has allowed us to really harness that data. So things like when we come to crop monitoring, agriculture support, you can imagine when the crop starts coming out the ground from sowing to all the way, when it's maturing, you have different stages at which we want to monitor and sort of also give inputs to the lenders, to the support system of the agriculture. And this becomes available and easier because of the availability of this data. So these problem statements are not just restricted to agriculture, right? So as Phil was also talking about infrastructure, utilities, if we really want to solve things for the nation level, the amount of data you have to crunch is huge. And it just doesn't stop at the crunching of the data. There is a lot of EDA because the data doesn't come up with very sanitized way to be absorbed and do analytics, right? So there needs to be having like a stack where this data is democratized, and then you have multiple layers like microservices, which AWS also has, to be able to then process the data or make it in a fashion which can then be having capability to do the analytics for. So having that kind of load being taken up by partners like AWS, we are now venturing into these situations, these conditions where we are tackling really huge problems. Wildfire management, vegetation management, agriculture monitoring, the scale is huge. And he just talked about the climate change, right? And that cannot just happen on a district level. That cannot just happen on a farm level. We have to study continents and across time series, across space. This is only possible because of the compute and storage, which we have seen in last few years. So specifically, AWS has S3 and EC2s, which has literally enabled us to do that. Imagine you and me downloading this data, analyzing on a single desktop. We'll be just pulling our hair out, right? We won't be even done with one district by the end of the day. And now we have to study the continent again at the decadal level, like how these, climatic events have been evolving, what has been the fashion, what is the trend around. In addition to that, companies will not have the entire information which goes into those kind of problem statement. Let's take an example of climate change. As let's say a satellite company, I would be collecting optical data, but I may not have access to weather data. So then these places where we have open data, again going back to data democratization, if we have this open data available, structured, organized in a way that we can fuse, then we can have much more intel in developing models such as climate change and stuff. So I'm so glad that even AWS has this open data program where we have used so many of the very structured data like NOAA. From NOAA we have weather data, Sentinel, ESA has published very many open data sets. There is also weather data, right? So all of this allows us to fuse the information without hunting for it. Otherwise, we need to be experts in weather data, which we'll be spending, few months to really understand the science behind it. So this whole fusion comes into existence because we partner in that. So downstream really need that whole sort of gold mine of data set, which can then be used to solve these sort of problems. In addition, I think from the downstream side, as Phil was also mentioning, now the data has been being available. The compute has also been very elastic, which means data as a center, which has been democratized. Now, if you were to, I have to do anything with the data, it's all about being elastic on storage. So instead of one machine, if I'm working from district to let's say country level, I would spin up 50 machines. I don't even have to care about which machine, where to find it, or how to connect to it, like just bootstrap it, warm boot it, right? So this is all available on the infrastructure side. So this allows you to go from literally a very granular sort of farm level to all the way country level without even, stressing about it, or in fact feeling like we don't have the right skill set. So this whole idea of elastic storage, as well as this data democratization, has enabled us to harness more sort of value out of the data which has been at play. In addition, Phil has also touched upon the security, right? So if we were to maintain multiple copies of data, we will have to do things very much in duplication. The data has to be secured, governed, all the private information has to be masked out. all of this nitty-gritty you don't have to care about if the data is still at the center of your problem solving. So it's like basically the nucleus we are building, which is kind of like you can think of concentric circles in which data at the center and these layers becoming available with microservices and our capability of solving these problems, we are now able to churn the solutions faster. So at Satsure, again, like the agriculture is one thing we have had really good success in terms of scaling from farm to the nation level. And we've been able to also sort of enable low-income farmers to lend money, to basically ask for money and get it, approved. And the volume at which we were able to do is 2 million farmers. So, and this is just in the last 1.5 years, right? So imagine if this grows to really all the states of India, the scale is huge. And not only in India, there are nations like Africa, there are other nations where the same thing can be applied. So just wanted to give you a glimpse of, if somebody democratizes the data for us, there's this tremendous opportunity we have in different industries, which is not restricted to just agriculture, even infrastructure, climate change, where I know some people in the room are also problem solver. You can just harness the data and actually use that data to solve for it. With that, thank you.
Yeah. Thank you. So, in fact, the geospatial data policy, which has been announced by the government recently, should help democratizing the legacy geospatial databases in the country. I hope we are in that direction. So now I will request Naresh. Naresh, you kindly introduce yourself and tell a couple of words about your company also, then your views on the...
So, first of all, thank you for having me here. It's an honor to be a part of this panel discussion. So just to give a quick introduction about my background. So I have more than a decade of experience in the data science and the data engineering domain. My career has been primarily in the startups. So the last startup where I was working, it got listed on the public stock exchange recently, and in 2019 we started Tathya. So the focus on the Tathya.Earth, what we do is actually we are building a platform to monitor the the global supply chain of metal commodities and its impact on the environment using the geospatial data. So since Phil and Divya has already talked about, I think the different kind of data sets and available on the cloud like Landsat or Sentinel, and on top of it, I think the different sectors which basically the different kinds of use cases those data sets can be solved. So I'll just touch upon the two sort of areas why the cloud technology is essential for the businesses to adopt, and secondly why the the geospatial data is actually an essential component for the businesses right now. So let's say if we go back to year around 2006, right? So at that point of time, if let's say if somebody wanted to host their application on the internet, right? So they had to buy a physical, server of let's say X GB of RAM or Y cores of processor. Now, on top of it, you have to maintain those hardwares. You have to basically, maintain the cooling system of it. But then the word cloud computing actually came, right? So which changed the way from buying a hardware to sort of, subscribing to resources on the cloud, and you pay as per the usage. So as the few years passed, somewhere around 2014 or 15, so people actually started the resources on the cloud to store the huge amount of data, and that's when the concept of the big data came into the market. And at the same time, the frameworks which are related to the big data, like the MapReduce based frameworks like Hadoop, Spark, actually they came into the at the similar times. Cut short to the present times, in the last 10 years from 2013 to let's say 2014, those huge amount of data have been used to train the large machine learning models. And the recent example for that, the LLM models, what we see, the llamas or the chat GPTs, etc. So right now, if we look at the this evolution from the geospatial data point of view. So we have the tools available to process the huge amount of data like MapReduce base. We have taken at Tathya, as I mentioned, is the commodity industries where we are monitoring the global supply chain of the metal commodities. Now the question would be like, why exactly we are, doing what we do at Tathya. So if we look at the globally, then one of the major problem what we have faced recently is the disruption in the supply chain, right? And if you look at the last 4 to 5 years, the supply chain has been disrupted for the 3-4 reasons. One of the reasons is, let's say, the pandemic or the geopolitics or let's say the climate change. Now, let's say if I explain you with with a simple example, why the disruptions have become more prominent. So let's say if you are a steel company based in Asia or Europe, then for a plant to run on a daily basis, you requires the raw materials like met coal or the iron ore, which primarily comes from the geographies like Australia, right? Now let's say if because of the weather the flooding happens, or even let's say due to the hurricanes the ports operations get suspended or the mine operations get suspended, then your overall revenue might get for a toss, right? So to hedge against such risk, I think the businesses need to have the real-time visibility of the overall supply chain, and that's where I think the geospatial data is very important. So these are I think 2 reasons why I feel because of the the power of AI what we have right now, and the why the geospatial data is actually required for businesses to sort of adopt. And I think I'll just add I think few more reasons. Let's say if people who are actually starting new businesses around the geospatial data, and then I think there is a lot of support I think which is provided by the the cloud providers in terms of let's say the credits, or even you can be a part of let's say their accelerator programs where you can get the exposure of their networks, and the credits can be offset from the the usage which we do. So I think these are the I think few reasons why I feel currently the businesses as well as the individuals should adopt to the cloud technologies and the geospatial data.
Thank you very much, Naresh. See, in fact, 8-10 years ago, when we went to buy a laptop, we used to always bargain for a terabyte kind of capacity, and we didn't understand, the lacuna of having 2 GB kind of RAM, things like that. But today, in fact, I had been to Apple Store in Bay Area, a few months ago. I wanted to buy a laptop. So when I asked for, a MacBook Air, then the guy came and asked me, why do you need, what is that you need? Is it for, are you a developer, or is it for production or home use? Once you say, I'm not a developer, I'm not this thing, he will say, okay, I think 8 MB or 8 GB kind of RAM is enough, and 256 GB storage is enough. Yes, today everybody talks of, cost, less of storing power within your machine, but better connectivity to, store elsewhere. Even on mobiles, we are pretty much used, when you simply subscribe for Google Cloud or iCloud, on Apple ID we have something. See, we don't realize the importance, we don't delete mails which are 5 years old now, or mails with large enclosures. So we are all aware, or rather being unaware, we are using the cloud resources, and now experts are there to answer your questions. So I leave it to the audience now to ask any specific questions to the 3 expert panelists. So, or they will make further remarks. Any questions from audience side? Yeah, please feel free. No? All are waiting for lunch. Yeah, here it is.
I believe panel, anybody can answer what looks like the future of cloud computing and data centers. Are we going to keep on expanding the data centers, making them big, or we'll be more working on the compression techniques, or there'll be some transformational thing which will actually replace all the current technology? So just what's the future of cloud computing after 10 years, 15 years? Are we going to just keep expanding with the same technology, or will there be some technology which will replace the current ones?
You can use this one.
Can you hear me okay? I could probably stood up instead. I think there's several things that are going to happen. I think the first thing is the efficiency of data processing is going to dramatically increase. So if you look at the chipsets that we're now building, that is every time a chipset with inferentia, for example, that efficiency is going to continue to increase. AWS is committed to net zero. Our data centers are increasing either solar panel or wind panel, which means that they're going to be powered. So the energy used in those data centers, and I've had several conversations that we are committed to them being renewable energy sources. So that's the first thing. The second big change is going to be quantum computing. And the potential for that to accelerate data processing will dramatically speed up some of those data processes. So I think technology will advance, it will continue to do so. I think the third thing is the very nature of understanding of what data centers are and how they're used. And actually, as on-premise data centers get shut down, that in itself provides a cloud footprint. So never forget that cloud is designed very purposefully so that organizations don't need on-prem data centers themselves, that use air conditioning, that use energy, and the use of cloud actually makes that more efficient. So I think there's going to be efficiency. I think there's going to be technology development. And I think quantum computing is going to be that real step forward that allows us to move from, especially in the geospatial world, just to come back for 1 second, and it's a comment. If you remember one thing from this conversation, remember this. Latency is the new resolution. Speed of intelligence, speed of delivery. So if we can be more efficient in delivering the intelligence, you don't need to retain the intelligence result. And of course, the data doesn't need to be kept because you've got the intelligence from it. So those are three things I would point to. And once again, happy to debate over a coffee or a beer later in significant depth. Anybody else?
I'll probably add a couple of more things. Actually, the last one is really important, where analytics will happen on the device itself, right? So we at Satsure are also launching our own satellites. And the idea is to just do the analytics on chips, because most of the data, you end up just using 20% of the data in that whole image. So why even download and waste the storage and everything with the 80% of data? So I think that the industry is moving towards that. Let's do the analytics right up in the space, to only send actionable insights down the link. Another thing which you touched right upon is the compression techniques, specifically for geospatial. It is very much needed. It happens in medical imaging a lot, by the way. So compression techniques have advanced, and we are further pushing the boundaries. In addition, you must have aware of foundational models, right? So which means, how do you concise the information of all these billions of images into just one set of float numbers? This is happening today because we are working on this foundational model, which is going to basically summarize everything about that data and just kept it intact. So there are multiple areas in tech which is trying to reduce this footprint, as you rightly mentioned. Great question, Vaidev.
Naresh, you like to?
So I think on the storage part, I think Phil and Divya has already answered the question. So I'll just touch upon the computing aspect, right? So generally, the resources on the clouds are majorly used for two purposes, either for the storage part or on the computing part, right? If we look at the recent trend, right, of the Gen AI, so we would need, I think, in future more number of resources, or probably I think in terms of the GPU. I'll just quote the stats from the IEA. So let's say if you consume X amount of resources for the Google search, then you would require the 10x search for a 10x amount of resources to a search to an LLM model like the Chat GPT. So if I look at it from that point of view, so from the compute part, I think we would need more number of sort of compute power. But on the storage part, as they mentioned, if we have the techniques where we can store the data more efficiently, then I think it will go hand in hand. So, and apart from that, I think as Phil has mentioned, I think we also need to take care of the amount of sort of emissions at the back end which are generated, right? So if we have the solution for those problems, how do we run our grids of the data centers on the, let's say, the wind power or the solar power? Then I think first of all we also need to answer those questions, and then probably we can sort of increase the number of data centers and the number of computes on the cloud.
So any other quick question? Because I got a note from the organizer. Yeah, please. Maybe we will take another 5 minutes more.
Okay, sir.
Yeah, okay.
So as space agencies are launching satellites day by day, and we have a lot of satellites in the space, but some of satellites are not currently in use, but they are sharing the data with us regularly. So do we have any cloud data managing technology or any AI resource to manage all the data and storing capability of that?
One, two, three. Great question. If you don't mind me asking, how old are you? Just if you don't mind me asking. It's great, because it's a great question. It's a sort of question. So, just roughly, how old are you?
I'm asking that as we have a lot of satellites in the space.
No, sorry. How old are you?
I'm 18 years old.
Fantastic question. So, this is brilliant. And genuinely, I want to have more questions from people 18 and younger, because you're going to benefit from these things. You're going to benefit from these technologies that we're developing right now in orbit data processing. We're going to be moving cloud processing not only in orbit, but to the moon and beyond, and you're going to benefit from it. I think the question is, what do we do with all that technology, and what do we do with it? The fact that we can move processing, the fact we can remove clouds in orbit today, the fact that we've put a snow cone on the International Space Station, the fact that we do satellite communication from satellites to satellite, what's called data relay with companies like Rivada Space and OneWeb, means that you'll be able to benefit more and more from that and actually build applications and services that next generation needs to develop on. So it's a challenge, and there's a lot happening right now. I know that our CTO is very keen to put regions further away than just on the Earth, and I think that's going to continue to develop for us and beyond.
Is Gen AI will be helpful in that?
Yes, these are great questions. Yes, absolutely. That's exactly what generative AI is. So I think the main thing with generative AI is the models that allow us to ask the questions, but we need to figure out what are the questions we've got to ask. I think that's actually going to be some of our biggest challenges. What do we ask? The fact that we now know everything about the Earth, intelligence, queryable Earth is going to be potentially a thing. But what do we want to ask? What questions are we going to ask of these models? What do we need to generate? We talked about digital twins. If we generate digital twins, which is a second generation of the Earth, how do we predict outcomes? How are we going to start offsetting the challenges like maize yield in the US? Look up NASA and the development they're doing. They're predicting how maize yields are going to decrease. We need to generate that. We need to intervene. There's a whole lot of predictive analytics, definitely worth looking up. And then there's prescriptive analytics. Predictive analytics, if we carry along this road, what will happen? If we intervene, prescriptive analytics, what can we change? It's really important that we understand the questions to ask of the data that we have. And that's where generative AI is going to come into its own. Sorry, I get very passionate about this. I've been invited everyone to, I have 4 children and I get them to ask me questions all the time about these things. So you're absolutely spot on. Keep asking questions.
Thank you, sir.
Any other question, or if not, I will ask all the 3 expert panelists to make a one line.
So I have one question.
Yeah, okay.
So I'm keen to understand from a geospatial analytics provider perspective, where do you face the biggest challenge, whether it is in what process of the data lifecycle, whether is it from, so Phil mentioned about democratizing the data. So is it challenge about finding the data, or is it about, with the amount of data being, like what Phil, you have mentioned, exabytes of data, which means the amount of data that needs to be processed, again, the compute proportionally increases. So is the challenge finding the data, processing the data, or having the data is important, but having the right data at the right moment, at the right hands is the most important thing. So which comes into the data distribution part. So where is your biggest challenge? Is it data source, data processing, or data distribution?
So I'll probably take that first. So I think the use cases we have been tackling, specifically for monitoring, the monitoring is not real time. So right time, right place, I think that still can be a sort of P1. But the P0 is still standardization of data and availability of data. Right? So as I was talking about climate change and other things, if we are able to have weather data available at our fingertips, it's easier for us to just fuse it with agriculture performance and be able to solve for something. The standardization also has been is a big deal, and I'm glad that OGC is looking into standardizing all these formats and whatnot. But it does take a hit when you go from, let's say, aerial or drone to all the way satellite, because everybody has their own format. So then the entirety of your data pre-processing, EDA, just increases the overall effort you would ever spend on this. So what would accelerate us is data democratization, one, getting more open data sources, especially the ones which are very auxiliary, which are not mainstream, and then the standardization. I think if we solve for it, it accelerates the whole problem solving we do for the problems in these industries.
I think, let me make one comment. See, my experience, in ISRO has been, basically, first think of store properly the valid data, standard data. See, that is where once the data is acquired, there are a couple of guys, they see the cloud cover, they see any lot of stripes, missing scan lines, whether data is good enough to store, because storage was one issue which was always addressed, safe storage. And the power of analytics, I don't think we were thinking of immediately exploiting, and today there is possibility because of cloud. And even same thing I had seen when some time ago I visited, this Potimash data receiving storage in Toulouse. And believe me, one lady, she's having a bite, sandwich, something, just to see cloud cover sip. She was expert in separating, the cloud cover from snow cover, especially for data for Alps and all. And if cloud cover is found to be, say, 30–40%, straight away discard that. Don't send it to your storage at all. Servers all lined up in the back. But now that is gone now, because today, even in India, some of the startup companies building optical imaging or hyperspectral, they don't have any storage within their own company. They have hired resources from Amazon Web Services, I know, though I wouldn't like to name them. So they will store the data there. In fact, today all are talking, they say when a startup makes a blueprint of their activity for the next 4–5 years, they don't discuss about storage or receiving, nothing. They will hire the cloud resources. So analytics, somebody else worries, So that is the beauty when you start utilizing the cloud for geospatial sector. Naresh.
Yeah. So I think Divya has already talked about the standardization of the data, but I'll also talk about, since we consumes a lot of satellite imagery, starting from the thermal to optical to the SAR data sets. But the only options, currently which we have, as Phil has talked about initially, like the Landsat or the ESA, right? Because they have opened up their data sources to the public. Now, the major challenge what we have is, access to the availability of the data, right kind of the data at the right price. Because currently also, let's say if we go back, if we look to the, buying a commercial satellite imagery, I think the kind of pricing, I think currently it is, if we, build a product around it, what we do, so we require generally, data on a weekly basis. So if we incorporate the, the commercial data in our products, then the price will go through the roof. So getting the right kind of satellite imagery at the right price is also, I think, one of the challenges, I think, what we face. That's why, we latch on to these open source, projects like Landsat, ESA, and, as we speak, Bhuvan databases.
So, yeah, I think one last question, then we will wind. Yeah. Please.
So we are discussing data storage about the geospatial data. So you mentioned in data analysis, 20% is majorly used data and 80% can be not required.
Not required. So on the decision as to how we are separating this useful and not useful, because let's say if we are analyzing a forest fire, so if the fire is here on a point A and how it is affecting point B through its emissions, and if we are concentrated today on the fire aspect, but we might need tomorrow the emission aspect, and since we took the decision to on the edge level that we will focus on forest fires, so what happens to the data we lost on that day?
No. Let me clarify. What I meant is, if you are talking of, say, reasonably high resolution data, say something like 5 meter, there, keeping the data with, say, 40% cloud cover or discarding that matters. Suppose you are talking of 1 kilometer resolution data covering a vast area. There your interest may be to look at the movement of the clouds in a particular part of the year. There you will not discard that data even if it is 70% cloud cover. Depends on for what purpose, what kind of data you have acquired, and for what purpose either today or future you would like to store that data. So it all depends on that. That is why, the particular experts handling the data will take care of that. Suppose you are looking for 1 meter resolution data, which is hardly, 5 kilometer by 5 kilometer, a high resolution image taken from low Earth orbit, where you get 40% cloud cover, maybe you may like to discard the data. So it is the resolution versus the quality versus the purpose versus and all that. And today you may not like to discard anything also, because today's noise in the data could be tomorrow's signal. So that much resource is available on the cloud today. You can think.
I'll just add one thing. So yes, you're absolutely right. It depends on the use case. Just a corollary to this, I will say, if you're interested in just roads on the planet, right? Where are my roads and what are the new constructions going around in road? Why would I save something of water? Why would I save something for agriculture, right? So for those use cases, you already are looking for a particular feature and that's going to be consumed. The problem statement you just mentioned is absolutely. You may not be able to save the entirety of the raw data. Like, why would you need 13 bands if you already know an index which can give you the same information, which is made of only 2 bands? So the idea is that reduction.
Hello.
Can I save the index from that area while I do the analytics in the other part so that I'm not running against the storage? But specifically the problem of climate change and tracking the biomass, of course, they will need the entire history of decades to really understand anything about it. So those use cases are a little different. But then the modalities you use for those use cases is also different. But these are trade-offs you will have to make when deciding to store or not.
So I think with that, Phil, bear with me, I will not give a chance now, because I've got 20 minutes we have overshot after I received a written reminder from the organizers. So thank you so much, and I think we are well exposed to the possibilities and opportunities before us, bringing cloud technology into the geospatial sector in this part of the world, or maybe the whole world is also accessible when you talk of cloud. So thanks everybody, and a special thanks to the expert panelists, 3 of them with me. Thank you.
Thank you very much, Dr. V.S. Hegde and all the panelists for providing such valuable insights during this discussion. Your perspective on cloud technology for the geospatial sector have been truly enlightening. So at this point, we would like to appreciate the valuable participation and contributions of our esteemed panel members. To honor their dedication and insights, we will now proceed with the felicitation ceremony, for which I would like to invite Dr. V.S. Hegde. Can you please come forward? Please welcome Mr. Phil Cooper, Geospatial Technical Business Development Lead, AWS EMEA. Now let's invite Ms. Divya Sharma, Vice President at Satsure. Now we'd like to invite Mr. Naresh P, CTO, Tathya. Can we please join our hands together once again? And now I would like to invite Mr. Rajat Ali, SIA-INDIA Senior Advisor, to felicitate Dr. V.S. Hegde, formerly Chairman cum Managing Director, Antrix Corporation Limited, and Scientific Secretary, ISRO. I request all the Well, ladies and gentlemen, we will continue with our next panel discussion, which will begin at 2:30 p.m. We appreciate your patience and look forward to your presence for the next panel discussion.